The first question on the Molecular Methods handout asks you to draw a southern blot to analyze blood samples from 3 individuals. The 3 individuals we're looking at are Bob, who's homozygous wild type, Irene, who is heterozygous. She has 1 wild type allele, and she also has a deletion allele that we'll call B. The third person is Jim. Jim is homozygous for a point mutation that we'll call the A allele. So in order to do a southern blot, we're analyzing DNA, and the first thing that we need to do is to chop up the DNA into manageable sized pieces. In order to do this, we'll do a restriction enzyme digest using Bagel2, which will cut this region of DNA at the Bagel2 sites indicated on the schematic. Now in Bob, the wild type individual, that's going to cut the DNA at these locations, and so he'll have 3 fragments from this area of these sizes indicated, 1, 1.2, and 0.5 kb. Now Jim has this point mutation here, but the point mutation doesn't affect a Bagel2 site, and it also doesn't create a new Bagel2 site at that location. So in terms of the size fragments that we'll see, his DNA is going to look the same as Bob's. Irene, since she's heterozygous and she has 1 wild type allele, the wild type allele is going to also be cut into these same size fragments. So far we're not seeing any differences between these 3 people. So we're going to look now at the deletion allele of Irene. Now the deletion happens to destroy one of the Bagel2 sites by just deleting it. If the Bagel2 site had been eliminated just by a point mutation that changed the recognition site so that Bagel2 could no longer cut there, that would cause a 1.7 kb fragment when the 1.2 and the 0.5 are added together. But in Irene, it's not just going to be 1.7 because she has the 0.4 kb deletion. So 1.7 minus 0.4 is going to result in a 1.3 kb fragment. So we'll see that fragment as well for Irene. Now we want to be able to visualize the differences between these individuals by running the fragments out on a gel. And in order to see these specific pieces of DNA that we're interested in, we need to have a probe that's going to hybridize to the DNA. Now the probe could be radioactive or fluorescently labeled or something like that so that we're actually able to see it. That detail is not important here. What's important is to figure out where the probe will be. So suppose we just put the probe at the beginning of the sequence here in the 1 kb region. If we did that, it's going to hybridize to the 1 kb fragment that's present in all 3 individuals. So that's not going to be helping us to tell the difference between these individuals. So let's consider some other possible locations for our probe. If we put the probe in the 1.2 kb region, again, it's going to hybridize to a fragment that's present in all 3 individuals, but it will also hybridize to the 1.3 kb fragment that's present in Irene. So we can draw out the gel and see what the bands will look like for Bob, Irene, and Jim. As we said, there's going to be a 1.2 kb band that's present in all 3 of them, and then Irene, in addition, will have a 1.3 kb band. So we're able to tell the difference between the B allele and the wild type allele with this method. There's some other possibilities. We could put the probe over here in the 0.5 kb region. If we did that, it's going to hybridize to the 0.5 kb fragment that's present in all 3 individuals. And it'll also hybridize to the 1.3 kb fragment in Irene. So you would see a 1.3 kb band in Irene on that gel. One other place that you might think of putting the probe would be in the deletion region. Now if you did that, sort of depending where within the deletion region you've put your probe, if it's in the 1.2 kb area, then it'll hybridize to the 1.2 kb band that's present in all 3 individuals. However, it will not hybridize to the 1.3 kb band that is present in Irene because or the 1.3 kb fragment that's present in Irene, thus there will be no 1.3 kb band because the region where you have the probe here is deleted in that 1.3 kb fragment.